Hi, everyone. Thanks for attending our talk today on tips and tricks, how to find and prevent MongoDB database issues in PMM. My name is Kirsten Foon, and I'm part of the marketing team here at Percona. Today, I'm joined by Divyanshu Soni, our MongoDB DBA2 in managed services. In his role, he sees a lot of MongoDB database challenges, and he's going to share some of his best practices with you. Before we do get started, though, a few housekeeping notes to go over. All lines are on mute for the duration of this call. Questions can be submitted at any time on the Bright Talk console where that little question mark is. We'll try to get to as many of them at the end of the session as we can. And for any questions that we don't get to, we will create a blog post to address them. This session is being recorded, and slides and the session will be available for replay afterwards. And with that, I'll pass it over to Divyanshu.
Thanks a lot, Kirsten. Hi, everyone. My name is Divyanshu, and thanks for joining this webinar. In this particular talk, I'll be discussing about what are the common MongoDB issues which people often face, and how can we find that out and prevent them happening with the help of performance monitoring and management, right? So as you can see my screen, we have list of items in our agenda, which we're going through one by one, right? So before starting, I would like to give you a bit of overview of PMM. How does it works internally, and how does helps to propagate all those matrices, which we'll be discussing later on. So it's basically an open source tool which is offered from Percona. It's also built on open source technology such as your Victoria Matrix, Prometheus, Grafana, ClickHouse. So I'm not going to dive into that because that's part of a different talk. So, but for understanding, this is how the major components will look like. So PMM server is basically a central component, which collects and aggregates the OS level and database level matrices from all those database nodes. On top of that, which we are running PMM clients background process, right? So this is how it process flow looks like, wherein it works on the push-pull matrices, all those matrices from all those database nodes gets pulled with their own exporter with the help of PMM agent, send it back to the PMM server, and then it processes it, and shows you a beautiful web console, in the form of matrix. So, okay, so what are all the dashboards which I personally found it helpful, even though there are a lot many. So these are the list of dashboards available, which are quite helpful. So we'll be going through one by one, like how they can be helpful to identify the underlying issues in the database which are currently happening, right? So, okay, so these are the common MongoDB issues, and we can, pick one by one, walk through them, and with the help of PMM, identify their underneath issues. So first one is the most common one, wherein let's say you're not getting a satisfactory performance out of a database, or slow responses, or even sometimes database itself become unresponsive, right? Not accepting any connections. So you start seeing a lot of timeouts, lot of 5xx errors from your application end. So these many things, right? So what could be the reason behind that, right? So to be honest, like there could be many reasons behind that, but we have to figure out what exactly is happening. So with the help of like I've shown in the previous slide, this MongoDB cluster summary, which is a particular dashboard wherein you can find out what exactly is happening on top of your cluster level, right? So if you log in PMM for the first time, it will land you to the home dashboard. From here, you can click and directly head it to MongoDB cluster summary, right? So here you can see a lot of information is available, wherein like you can even select the particular cluster, wherein you find out the metrics, what exactly is happening, and the time frame as well in the past X hours, like what all the activities being performed. So cluster summaries basically tells a bit of details about your databases. Let's say I've selected the sharded cluster here. So if you know that's part of a multiple shards. You have config server replica sets, the Mongo has cloud routers as well. So as you can see, a lot of information is available here. So as you scroll down, you can get to see how many connections are established per shard, how many total collections cumulative from all those shards, and what all the currently cursors are active, right? And how many MongoS cursors are active, how many operations per shard is currently going on. So if you can see it here, these three shards I have tick, tack, and toe. So you can see how many operations are going against. So you can see the spike here is because a while ago I have loaded a lot of sample data, which is why you're seeing the spike here, just to show you. Here you can see the total number of Mongo operations, which obviously have performed a lot of insertion. That's why you see the spike here as well. And replication lag per set as well, right? Each shard will have secondaries as well. So per sharded environments we are showing a replication lag here as well, including the oplog range as well, like how much oplog window is currently available based on the current oplog size. Right? So all these informations are available on the MongoDB cluster summary dashboard specifically, which is basically going to help you identify what exactly is happening, right? If you are seeing a certain issue, you're starting seeing slow responses or even database got unresponsive, so you can find out like what type of operations are running, right? Is there any heavy reads? Is there any heavy writes are going on? And is there any particular shard is being targeted for that particular operations? Or talking in terms of replication, even might have your primary becomes overwhelming. It utilizes all your underlying hardware resources capacity wherein it cannot perform more operations. So any operations are coming against your database from now onwards will end up in the queue, right? Or times out basically. So you know to find out what exactly is going on, right? Uh, Another thing you can see is basically you need to have answers ready for all these questions in most of the scenarios. Like if is there any recent deployments from the application team which might have enabled some sort of a service which started building a lot of connections or introduce some sort of queries which are not at all optimized, meaning that they are doing a lot of collection scan or they are not indexed properly as expected, right? So these are all the issues can contribute to overall database performance, meaning that let's say then what you need to do, you need to check what all the type of operations are running, right? Now that you find the operations, you found out that you know there are concurrent heavy reads are running, heavy aggregations are running. So what they are trying to do is basically if they are involving lot of disk because of those activities, as you all know, if you are not reading from the white tiger storage engine cache, if you are going to the disk, that is basically a costly operation. It takes a lot of time. Latencies will also be involved in that, right? So for these underlying, resource contention, basically we have a separate dashboard available. So instead of MongoDB cluster summary, if you go to this OS tab, let's say I'm just going to the disk details to verify that if it's an underlying disk issue, which might have triggered this performance issue altogether. So let's say I have selected a time frame. These are all the metrics which are showing how much the data has been utilized per partition. Now, the important metrics I would look for is the disk latency. Disk latency, if it's increased, obviously you will end up seeing a lot of slow operations, right? And even if you can see here, how many IOPS are currently being utilized, how many read IOPS, how many write IOPS at the same time, how much bandwidth you are utilizing of the currently allocated disk, right? What is its exact capacity, how much it utilizes, how much is disk IO utilizations. So most of the time, what I have experienced in the past is because if you have poor queries, what they are trying to do is basically they're not finding anything from the cache layer, from the white tiger cache. They directly hit the disk. Now, if they are hitting the disk, there will be unnecessary blocks read, right? So for that, IO utilization will start increasing. So if it's reached 100%, then boom, everything will start stalling, right? So you need to make sure that you're avoiding any involvement of the disk. Now, how are you going to do that? Is basically making sure that you have sufficient amount of resources available. Resources as in sufficient amount of memory available. If you have more memory, means you can utilize better part of that for the white tiger cache. Basically, it's roughly 50% minus 1 GB, right? If you guys know about that. So if you have more white tiger cache available for any operations are coming up, more cache will be used to store the result set of those query. So this can completely avoid it for that. So any new queries coming up, it can fetch the data from the cache, return back to the user. That's it. You will get the best performance out of it. So that's the thing. You have to avoid disk involvement as much as possible. That makes me take you to a different dashboard. Like now that I'm talking a lot about the story engine, right? So there are more important which are taking one by one. So let's go ahead in the white tiger details first. So I'll be using the replica set for this particular demo because I've heavily utilized it. Okay, I know that RS2 is the primary. So just I'm showing from the primary perspective and from the secondaries, right? So in the white tiger details, as you can see, there are a lot of metrics available, right? White tiger transactions, cache activities, the block activity, the concurrency metrics as well, how many operations are queued, the cache eviction, checkpoint time, right? So talking in terms of that particular issue, wherein your database become unresponsive or something like this is one of the reasons, right? It utilizes 100% of your IOs, you know, and even you are experiencing a lot of CPU. So what it makes is basically anything coming up, any new request coming up, either gets wait in the queue or ends up with a timeout, right? So now that you need to figure out how much is activity going against the white tiger cache. Is it sufficient enough or not, right? So here you can see the important. This is the internal transaction which basically happening inside the white tiger, right? Not the regular database transactions. Now here, white tiger cache activity, as you can see, right, this particular graph. So this is important. What are the two plotted values here is read into and return from, which basically means that if you're running a find operation, and if it doesn't find anything in the cache layer itself, first it will look into the white tiger cache. If it doesn't find any relevant pages recently cached, it looks for the file system cache for the few of the times. If it doesn't find that, it start hitting the disk, right? You start hitting the disk, loads the block with the help of file system caches, start uncompressing them, right? Because all those pages are stored onto the disk are compressed basically with the different compression method we have. So the pages, the blocks get loaded with the help of file system cache back into the white tiger cache. So you can see the process. A lot of compression, decompression is going on, right? Because in the white tiger cache, you have to store pages in the uncompressed format. So as you can see, there is a spike in the read into, right? Basically means the pages are reading, pages are getting reads from the disk back into the cache, right? So it basically signifies that you didn't have those particular pages for that particular query results, right? So if you're seeing a lot of spike in a similar way, that means your cache itself is not sufficient enough, has to involve a lot of disk, some sort of things. Another is return form is basically nothing, how much data you are writing from from the white tiger back to the disk with the help of checkpoints, right? So this is basically for the for the write intensive workloads, like for the any write operations going again. And then comes the white tiger block activity. So it basically means how much you are reading basically within the white, how much blocks is basically reading. So if you hover it around, you can also see the descriptions if you guys sometimes get confused between few of the matrices. So these many reads are currently being happening at that moment of time when I in the backend when I executed a find operation, right? These are all the sessions which are currently active. So if you're seeing a lot of spike here and there, you basically understand that okay, there has to be some changes happen from the application, and you can verify from them. Is there any set of queries which you have deployed which are not optimized enough? So these are all the symptoms wherein you can find out that particular issue. And another symptom wherein the database become unresponsive is basically your. So if you guys know, there is a concurrency method is implemented within the white tiger story engine. So 128 tickets basically parallel for the concurrency methodology of read 120 tickets allocated, write 128 tickets allocated by default. So because of those slow operation, if they used to get allocated or utilized completely. You don't have any tickets available at that moment of time. Any new operations will end up in the queue, right? So we start seeing grow in the queue as well, right? So here you can see it's just the one ticket is utilized. There is, you can see a larger spike here, just the one ticket. So the point is, if you are seeing a lot of utilization of tickets here as well, you know that you are hitting the concurrency issues, right? And same as the checkpoint time as well, like how long the checkpoint took able to flush or evict pages from the cache back to the disk, right? So this is another white tiger cache eviction graph, which helps, basically tells you if there is a cache buildup, right? So if you are seeing a lot of large spikes in white tiger cache evictions, basically means there might be some modified or unmodified pages being evicted out of the cache. Modified pages are basically wherein if you are performing some write operations like your insert, updates, and delete, the pages gets modified, and then at every checkpoint they get flushed out from the disk, right? So if you're seeing a lot of spike for even for the unmodified pages, especially unmodified pages, basically the clean pages, right, for the read operation which gets read into uh, cache from the disk during the warm up, right? So if you see a lot of spike in there as well, you know that your cache is not sufficient enough to handle that amount of read operations or write operations at point of time. Okay, this white tiger cache capacity is also an important matrix, even though all metrics are important, right? So this basically is tells you how much is a maximum cache configured and how much is currently used one, right? So if you know that the total memory available on the server, the white tiger takes 50% minus 1 GB. So on a larger scale server, it's basically roughly 50%, you can say. So let's say here I have hardly configured for 1 GB, and if there is a soft limit of 80%, right? So white tiger basically maintains overall 80% of the white tiger cache usage, at any given time. If it grows beyond that, start evicting the pages, right, with the eviction threads internally. So most of the times, if you're seeing a lot of spikes here, then obviously the small spikes here, if you can see, there is a small spike. And at the same time, there is a spike in cache eviction as well. So now that you know the cache usage grows beyond 80%, right? That is why it has to perform evictions, because in order to make room for the pages has to be now they are in the white tiger storage cache, right? It has to make room for that as well. And at the same time, it has to maintain the 80% usage, right? So you need to keep checking a graph of this cache capacity as well, right? Cache pages, here you can see the total amount of pages are currently being in the cache, white tiger cache, and how much amount of dirty pages are there. So if you're seeing a lot of dirty pages, right, you know that have a write intensive workload, all of a sudden write operation has increased, which resulted in increase in the write pages within the cache layer. Now, similar layer, similar threshold is also there applicable for the dirty pages, right? So 5% is basically the soft limit, 20% is basically the hard limit, right? So if you're 5% out of your total cache size, right? If it reaches amount of dirty pages reaches 5% of your total dirty cache, I mean the cache size, what it does, if it doesn't wait for the checkpoints, right? All those background eviction threads, right, keeps on flushing those dirty pages, making that persistent to the data files. It doesn't wait for that checkpoint, right? Otherwise, it would have taken every 60 seconds for the checkpoint, to make sure all those dirty pages return. But the point is, if you are seeing a lot of spikes, large spikes there, which basically signifies that always you are hitting that ceiling of 5%, 6%, 7%, you know that it's struggling a lot, to finish that amount of work in order to make those dirty pages flushed out of the disk, to make them persistent enough. These are all the metrics. Similar, you can see it are basically for the write ahead log files. So you can see I have inserted a lot of documents at the same time. You're seeing the write and flushing how much is happening, and here you can see the amount of compressed, white tiger Right-hand log files pages are being written, log activity, document changes, right? All sort of things you can see in here. Even you can see page faults here. If you're seeing a lot of page faults, it means that the workload is beyond the point that you have maintained with the cache itself. There's another drop-down menu. You can select it, MongoDB summary, wherein you can see per node connections, how many connections you have established, how many cursors you have, and then you have node summary, wherein you can see the CPU usage and per core CPU usage, maximum core CPU usage, all sort of things, and how much amount of network traffic also you can utilize, right? So if you can see, it's significantly fine because I'm running a lot of MongoDBs on top of single server. But if you're seeing uh, a lot of IO weight percentage, that that CPU cycles are heavily involved because of doing lots of work, right? So these are all the things will make you identify the underlying issue. Is it because of the disk which is hitting the ceiling, hitting the 100% utilization, so that you know that there might be some poor queries running or some aggregations are running, right, which might have ended utilizing all those resources. So what are we going to do now? So I would definitely say that it's not easy to have a short-term solution. So what you can do, if it's feasible for you at that moment of time, because your database become unresponsive, you can buy out some time, upscale the resources, probably in the rolling manner. That will scale up your resources and might have help to basically continue to handle that workload. But as a longer term, if you know that the operations are not at all optimized, you have might have to reach out back to the developers, application team, saying that there has to be some sort of optimization, so any involvement of disk can be avoided, right? Next is scale your reads. So basically, scale your reads basically means that you have to use proper read preference, if at all possible, to avoid any overhead from the primary, and move the secondaries to move the reads to the secondaries, for those read operation. In some cases, they have business requirements wherein they cannot afford to have stale data coming out of the secondaries. That is a different case. But if it's all possible, use a proper read preference and the right concern as well. This is also important. That so apart from all those metrics, you can utilize even db.current top as well. So what exactly happening in the real time, if there any locking is happening, even though you can see it in the queue as well, which I have shown you earlier in the cluster summary. But if you can go to the cluster current opers also, you can get those details, right? So right concern, why it's going to affect you is because if the workload has increased, that might have end up, uh, there are some situation wherein you end up with replication delays as well, right? If your application is delaying, so let's say 10 seconds, 30 seconds, right? Then if you're inserting lots of bulk inserts, you're doing bulk deletes, you're doing. So what happens if you are using larger value of write concern? Now at the same time your secondaries are lagging, right? So what it does, it what basically does is basically every secondary has to acknowledge that, right, it's propagated from the secondary. Now they are lagging with their primary, it has to wait that much amount of time, it acquires the log, all sort of things are happening, right? So if at all possible, reduce the write concern and make it one, so that just the primary acknowledges it, and we will get the acknowledgement in the driver's end. If at all possible, implement it, right? Large queues, like I said, this could be a reason wherein tickets, why tickets utilize. Now why it utilize? Because of the underlying CPU spikes or disk utilizations. Like I said, poor queries, we have to identify them and find out the fixes. Has to be properly indexed, right? High memory consumption, there are yeah, high memory consumption. So now that, apart from all those overall issues, large scale issues, we are starting seeing specific alerts, high memory consumptions on a particular node, let's say on the primary, right? So you need to identify how many connections, right? How many connections currently established, because you know each and every connections utilizes some part of a resources, right? That's roughly 1 MB per connections, right? So let's say if you have 128 GB of box, out of which roughly 60 to 63 GB will be allocated to White Tiger cache. Now the amount of memory left mostly will be utilized by the file system cache, right? So this is how the architecture of Mongo is, right? Remaining memory it utilizes via the file system cache. So beyond that White Tiger cache area, it basically use other part of the memory, remaining memory, to maintain those connections, right? So let's say you have 64 GB left, like available memory, and you have like 10,000, 20,000 connection multiplied with one memory, you will get that much utilization roughly, right? So these many things. And if you are running large shots, right, even though if had a hard limit of 32 MB for a regular file sortings, or for larger aggregations 100 MB. But you got the point. If you're running a lot of such operations, they also utilize a lot of memory. And if, if you, let's say you have uh, if you wanted to get rid of that as a short-term solution, or maybe as a best practice, you have to make sure from the driver's end they are closing any unused idle connections to give room for the new connections, right? Otherwise it will also become a bottleneck, right? Sometimes you have a hard limit on the database layer itself, maximum incoming connections, or U limits as well applicable, right? So you have to take care of all those things. So the best thing is always prefer to close any unused idle connections, right? Either via the connect timeout or socket timeout, something like this, from the connection URI itself from the driver end. And pinned cursors or tools, right? Pinned cursors basically you've triggered a query and implemented no cursor timeout, so it will just remain active, right? Otherwise it would have timed out. So try to avoid any pinned cursor because it also utilizes a lot of resources, and pools, basically connection pools I was talking about. So like if you have large connection pools, with 10,000 connections, each pool will be, roughly how much connections it has created with, basically uses some sort of memory, right? Similar to ending idle connections, right? Unused idle connections, you have to make sure that you're not overwhelming your database nodes with a lot of pools, right? Okay. The next is high CPU and disk utilizations, right? So CPU is basically a very easy way to find out, right, what could be the cause, right? Even disk utilization, like I said, so you need to identify what type of workload you are running, right? Is it a read intensive workload? Is a write intensive workload? And how many operations are running? How many inserts, update, deletes, and how many find operations are running, right? So based on that, you can calculate, the number of IOPS, the number of disk bandwidth you're going to utilize, right? So let's say if you have a disk dedicated with 10,000 IOPS, right? And now that you are running write intensive workload with end up utilizing more IOPS than available, then obviously again you are hitting disk bottleneck, right? Which is a classic case for that. So what you need to do is basically plan ahead of the time, right? Don't just wait for your server capacity has been reached, then you are thinking something. Just plan ahead of the time that this is my growth, and these are the number of operations I'm going to use in the future. Okay, another important thing which I feel that tends to get often ignored, right, which is hard to analyze and calculate, is the working set, right? Working set is basically the amount of active data set which you currently use, right? Is basically the summation of the number of records you are accessing frequently along with their relevant and indexes size, right? So if your working set is beyond the white tiger cache, right? Then obviously involving a lot of disk, right? Lot of disk means lot of CPU cycle will also get involved in order to do that work, right? The compression and decompression also happening at the same time because of involvement of disk. So make sure that you are evaluating your working set, and just make sure it fits well within your white tiger cache. If needed, upscale your instances with more memory so that the cache size can increase and it can fit well within inside it. Now, high white tiger cache eviction, like I said, you here is basically if you're seeing lots of spike, right, in the white tiger cache eviction. Basically means that your cache pressure is starting to build up, right? The cache is not able to uh, handle that much amount of workload. It has to flush out lots of pages out of that, in order to keep that 80% usage mark, right? So if it's happening, you have to have more memory. So most of the times everything comes down to the same thing, that we have sufficient amount of resources available to keep up that with the workload, right? So that's the thing. Now the next is too many indexes, right? If you know that for the read operations, especially, having a better indexes is just fine. There's no issue. But they comes with a trade-off if you have write intensive workload, right? Any write is going around, like let's say if you are inserting something, update or delete is going on, you know if you have too many indexes, all those index entries has to be updated with that respective write operations, right? So if you have too many indexes, you are doing a lot of work in the backend, right? So make sure that you analyze your indexes regularly. Like analyzes, by analyze I meant that run an index stats regularly on top of your collections, right? And find out what all the indexes are haven't been accessed from a longer period of time, to make sure that they are now being not used, so we can get rid of that. But always uh, fully be sure about that before dropping it into. We might need in the future, but still, if you're sure that they are not going to be used, just drop them. That will eventually improve a lot of performance. Another thing to test it out, basically redundant indexes, right? So basically, if you have, let's give you an example. If you have a compound index on first name, last name, right? Another index which is a single field on just the first name, right? So the optimizer is intelligent enough, even though if you're running a query or just on the first name, as it's a part of the prefix of both the indexes, the single field index will become kind of a redundant form for it. So even though if you don't have this, right, it can still use that compound index for that same operation because it's the part of the prefix, right? So make sure that you don't have too many redundant indexes per collection, especially for the larger collections, because it takes a lot of IO. Roughly, roughly, let's say for every inserts there will be one plus the number of relevant indexes. These many IOs will be utilized. Similarly for the deletes. However, the updates is because that's how updates works, right? It loads the pages back into the cache, updates it with a newer version, discard the older one. So that's two plus number of indexes which are relevant for that particular operation. So that's how overall IOPS you can calculate, get it with an idea. Let's say 1,000 inserts, updates, and deletes you are running. You will get a rough idea about how many IOPS my particular server needs, in order to fulfill that workload. Yeah, next is the poor queries, right? So the poor queries, basically the queries which are not optimized enough for your workload, basically is doing a lot of collection scam. For that, I am going to just move on slightly to the next slide. Okay, we'll be going to use the query analytics feature for that, right? So it comes along with PMM. It's a built-in feature. Now, how does it work? It basically needs profiling to be enabled, right? Uh, if you explicitly need a particular database needs to be evaluated or analyzed with the help of query analytics, just enable the profiling for that, or else enable it globally. But not let it be enabled for most of the times. It's just whenever you need it, when you find that there's a peak time and you wanted to analyze the workload, then just enable it for a period of time. The best suggested value is 1, along with specific slow ms, like slow timeout, slow milliseconds. Say 100 milliseconds is a good starting point. So what it does internally is basically queries system.profile collection to gather statistics about the queries which are running, right? So I'll quickly go it here. And as you can see, the query analytics appears up here. So you can click here, right? Similar options are available here too. You can basically select the time frame. Let's say I have selected 3 hours. I guess there is I'm running a batch job in the backend, which might have appeared up here. I can show you. Yeah. So let's say I've selected a time frame in the past 12 hours. These are few of the queries which I have executed, right? So let's take a look on these two particular finds. This is basically a an experiment on top of the find. So for this particular find, if I click on here, you can see basically a simplified view what you are seeing either in the logs or the system work file collection. So you can find out how much time it took, how many times it ran, and how many documents it has returned, and how many documents when actually scanned, right? And all sort of things. The response length as well, like how much data has sent it over. And if you can see in example as well, you can see the past, basically the past format of that, right? How the exactly the query looked like. And if you go to the explain plan, which is the point where we'll start analyzing the queries itself, right? Whether they are not, whether they are doing a collection scan, how many documents they are necessarily scanning, and how we can improve that by writing the index and what all the particular fields which we can index on top of that, right? Okay, let me just refresh it. Okay. Okay, yeah, there we go. Might be some glitches in the backend of the server. Anyways, this is how the actual explain plan, which is basically fetched from the system work profile. So as you can see, the namespace is here, the past query, the past query, like how the query has been passed by the optimizer, right? So you can see the I started using the or clause, right? I'm looking for age, and I'm looking for name, and this is how my billing plan looks like. I'm doing a collection scan, which basically uh, the worst part, right? And I'm not utilizing any indexes. I'm just doing unnecessary scanning of the disk, right? So we have to avoid that. Now, how we can, optimize it? Basically, first of all, we need to get rid of this collection scan, right? Now I'm running an OR clause on age and name, right? And those who know like how optimization actually works, this OR operator is basically splits those particular fields and runs a subquery, and then aggregates the results which comes out, and generates the result on top of that. So for this particular query, we can have a single field index on age and another field on the name. When you execute that query, the age will be the age subquery will be executed separately, the name subquery will be executed separately. They both will be utilizing the index, and then fetch the relevant documents, right? Because that's how it works, that's how index works. It basically looks for the index entries in the binary tree, look for the relevant document, look for the offset onto the disk, fetch that particular block, go into the cache, discard remaining bytes, and then return you the results. Right. So you have to make sure you're using this particular explain tab to identify what exactly the billing plan looks like, what all the stages are here. So let me show you another query. Yeah. So as you can see here, I have used a regular expression on name. Uh, Still, I'm doing a collection scan because I know I don't have the index, and I applied the limit. This is not going to be effective, but you got the point, right? For this particular query, you can have, according index accordingly, and then just completely avoid the collection scan, right? So this is how it's going to work for this particular issue, like I have mentioned, for poor queries. Now comes the issues with the replica sets or sharding, right? Majority of the times, the issues are your replication delays, right? So, or even in the sharded environments, we started seeing lot of slow chunk migration, and they end up sometimes with failed migrations as well, right? So what could be the reason behind that? So for especially for the replication lag, we need to identify if is there any bulk operations, like especially bulk write operations have been executed against the primary, right? So let's say if you are inserting 10,000 records at a time with the bulk operation, even though it's a bulk one, but still it will generate single entries in the op logs, right? 10,000 entries in the op logs. Now, how secondaries will fetch? Basically, it will fetch in the serial manner. All those 10,000 op log entries will fetch in the serial manner, and then with the help of the replication threads, it will apply them in the parallel. Like roughly around 16 concurrent threads are there. Yeah, but anyways, at the beginning, it has to fetch all those 10,000 oplog records one by one in the serial manner. So you can notice the amount of work has been done. And if on top of that, if you're you know utilizing a lot of secondaries capacity with a large amount of batch operations, like some kind of a reporting, that also utilize our sources. So all those things will contribute in your replication legs, right? And obviously, we cannot ignore the network part. Like if is there a network congestion, it also comes into a play, right? And sometimes, let's say, if you have chaining enabled and you have set a sync source to a particular secondary, which itself is overwhelmed, then also obviously you're going to get a lot of replication lags as well. So all those things we have to carefully notice. That will give us a better understanding of what exactly is happening and good starting point to start our troubleshooting process. Right. Another thing is solo chunks migration. That is basically an issue in the sharded environment. So as most of you know, like how the chunk is being migrated. Like so, there are basically total 6 steps which are being performed if the chunk has been picked up from the source to the destination site, right? Just perform some metadata checks, then start making the clone from the source shard to the destination shard. Then once all those operations are, all those documents of that particular chunk is being cloned to the destination shard, then you start the deletion. Now the cloning and the deletions are the most time consuming part. So if your source or destinations are either of them are overwhelmed already with the workload, then obviously you're going to see a lot of slow chunk migrations, right? So there are some mitigations for that, but anyways, not going to be part of this talk, but still I've given insight like what could be the reason and what could be the symptoms basically for that. If in the action log, if you can see, these are step 1 to 6 will be mentioned, and step 4 and 6 are basically the part wherein the actual cloning and at the last deletions actually happens, right? So if you're seeing lot of time is being consumed there, then you think about looking for the disk and CPU metrics at the same time, right? The relevant time when the chunk got migrated. Right? Next is the connection issues, right? Sometimes what happens, I'm basically ignoring the part wherein you have some sort of U limits or the configuration parameter like maximum incoming connections are there, right? Kind of ignore that because already most of the people follow the best practices for that. So other things are not using connection pooling at all, right? So what happens? It takes a lot of time to establish connection, let's say, right? Why is it happening? Because maintaining and establishing connections on any of the database involves a lot of effort underneath. Even though it doesn't look like, but you can imagine the scale wherein you're dealing with 10,000, 20,000, 100,000 connection at the same time. Uh, you might end up facing a lot of issues, right? So if you're not familiar with how that works, so basically the user sends a request, the database accept the connection. So basically internally uses this TCP methodology to perform the internal handshakes, and then it will be allocated with that particular connection. So maintaining the connection is also a costly way of having that. So how connection pooling is going to help us is basically to avoid that overhead of maintaining connections or establishing connection without the connection pooling, right? So how connection pooling helps is basically allocates pre-allocates part of the cache, wherein when you establish a pool, it pre-allocates the cache. So any new connections, you will be involving, right? Can be utilized from within the pool itself, because already authentication layer has to be performed, which is already done by the pool itself. So always use the connection pooling, because if you know, in nowadays Mongo uses Scramsha 1, Scramsha 256, basically a hashing function involved, for the authentication layer. That involves a lot of CPU if you have large amount of connections established, right? So it's good to avoid that using the connection pool because of the same reason, right? And again, the same thing which I have told you, we use timeouts for any idle connections, right? So that it don't stay idle there, and use the resources of a server, right? And the swap, or why swap, even though it's not preferred, is basically to avoid the out of memory issues on your servers, right? If your MongoDB process consuming a lot of memories, right? What happens if the kernel feels that is utilizing a lot of memory, start killing that process. Now, if you have some sort of swapping enable, the preferred is basically one. If you have some sort of swapping enabled on top of a server, then we can completely avoid that out of memory errors, right? And make sure you have proper U limits as well, like for the open files, for the stack size, like all sort of things you have to make sure properly tuned. And CPU utilization, I forgot to mention in the poor query section, is basically if you are running larger aggregations. Now, why aggregation is basically these are itself by design a costly operation, right? So if you know there is a unwind operator, unwind stage and the lookup stage as well. So why they are costly? Basically, let's say if you have a collection wherein you have documents with a field with large values of arrays, and the first thing is basically if you're querying them, that is fine. It can either be picked from the cache, or if not, obviously going to go to disk. Then it comes back to the file system cache, do some compression, decompression, and then the actual processing happen. If you have, let's say, unwind stage, what it does, it had to process lot of array values, right, in order to fulfill that unwind operation. So if you are feeling that if you have exhausted the amount of CPU cores available at the same time, like it reaches 100%, 90% most of the time, you know that there's an issue of the CPU. So probably in that regard also you can think about upscaling your instances and all, right, at the same time. But the point is of all this particular talk is basically the important part is understanding your working set, like understanding a working set. How much is a working set? Have to have. There's no way to calculate the exact working set, but you have to have rough amount of that, right? And now calculation of your IOPS requirement based on the query per second if you're getting, right. How many queries are running per second? What type of operations are running? All sort of things, right? And this is how. But to be honest, like most of the times I've said, like add more resources. It's basically a part of vertical scaling, but you will definitely going to reach at a certain point wherein you will not get the best performance out of it, right? Especially in most of the cases, this is applicable for the write intensive workload. Now, what's the reason behind that? It's because the single server cannot be able to handle that amount of workload if you reach a certain point of a certain limit, right? So make sure that you are planning well ahead of time, not just wait for that point wherein database is consistently being exhausted. Adding more resources not going to help you out, because also most of the people forget about taking care of their backup business requirements, their RTO and RPO as well. So having last data set, let's say 10 terabyte, 20 terabyte running on just a simple replica set, end up taking a lot of time in the backups and restore if needed, right? So roughly based on in most of the cases, like how much resources people generally uses, 1 to 2 terabyte is like max. Beyond that, you have to think about horizontally scaling, right? So for horizontally scaling, obviously you need to think about sharding, right? So you cannot just keep on vertically scaling. So for horizontally scaling, also you have to consider a lot of parameter like how you're going to distribute the data, how many shards do you need, how much resources do you need per shard, and what all the shard keys are you going to pick, right? So that it can evenly distribute. But make sure we are planning ahead of the time, because let's say if you are almost reached to a ceiling point wherein you cannot get best performance out of a server even though adding more resources. Now that if you are then migrating to a sharded environment, the beginning phase will be additional overhead, because assuming that you have chosen the best shard key which will help you to evenly distribute data, you have to balance out that 50% of data from the then replica set, which is now a sharded environments, right? Now to the new shard. So that also balancing process involves a lot of overhead on top of what it was actually serving, right? So just plan ahead the time, make sure that you have all those calculation with you, so that you don't run into some different issues altogether, right? And yep, there are, like I said, we'll be covering other dashboards as well. So like I've shown you cluster summary, which is basically shows on top what exactly is happening on the topmost level of your database, like how many operations, like how many connections per shard, all sort of things. Now we have instance overview here, right? So this particular dashboard is basically, shows you entire cluster at the same time, like all the database nodes of the particular cluster at the same time. For example, if I've selected the replica set, my replica set has 3 nodes. So I've selected a time frame. Now that you can start seeing uh, the connection status. So this particular dashboard basically helps you to identify if there is a busiest node out of a cluster, which might be a problem for you, right? So as you can see, the connections details per node at the same time, and what are all the cursors, right? And the query efficiency as well, right? All sort of things you can see here, right? And last but not the least, which is the most important, which I personally feel, is the instance summary. Okay, so as you can see, let me select the node first. I've selected the primary because most of the traffic I've generated is primary itself. So as you can see, the latencies, which particular operation, how much latencies, how many cursors, how many connections, right? How many document operations, queued operation, all those things you can get an idea from here what exactly happening, and the query efficiency, which is also important, like how much document scanning you are doing, right? When you're doing any index scanning, you're doing just the collection scan. So how much it is out of your total workload, how many index. So if you're seeing more document scanning rather than index, definitely you're going to hit the bottleneck of your disk or either CPU, right? It doesn't make sense to add more memory because anyways have the poor queries, anyways going to the disk, right? So have optimization of your queries to get the most out of it. Okay. Okay, we have covered this. Okay, tips and tricks. Basically, I have covered most of the things, but the important part is try to identify the root cause. Right? Most of the people tend to confuse with the symptoms. They think this is actually the root cause, but end up with finding just the symptoms. So identify the actual root cause, and work directly on that, and implement long-term solution. I have the times as proactive measure. Like I said, you invest uh, while I have the time either by vertical scaling or horizontal scaling to avoid any surprises of such issues. Right? Apply proper troubleshooting process. Like what do you mean by this is basically you need to start thinking about what type of workload it is. If there is any some poor queries executing, some sort of a query pattern itself is not good enough, like they are using some very bad operator, which is like or unwind, something like this, right? And then comes to other ways, if there is some kind of locking, right? How much utilization is there by the underlying resources, all sort of things. And last but not the least, implement whatever the recommended production nodes are there, right? You can find our own blog wherein we have recommended you the suggestion how to tune the operating system, the kernel parameters, the type of index, which is very very much recommended. All sort of things have been there, right? So it's always preferred to follow the production notes. And you can, if you have any questions, you can contribute by heading to our forums.pacona.com. Leave your questions if you have something. We'll be happy to answer them. And if you feel something, some new feature, if you want to have, if you're using our softwares or tools, you can just raise a request in the Jira, or even if you have some suggestions, right? You can just head it to our GitHub account, GitHub repo, raise a pull request there itself. If you find it well good enough, we'll definitely work on that. And last but not the least, we are hiring. There are many positions open currently, right? So if you are interested in this specific role, head it to our career section and start applying there, right? Okay. Thanks everyone. If you have some questions, leave it there itself, or if you find something else, like reach out to me later on. That was all about my talk. Back to you, Kristen.
Thanks, Devyanshi. There is actually a question that has come through. For a multi-tenant environment where about 50 to 60 different applications are running against their own databases within the same replica set, PMM query analytics not enabled, what would be the best approach to identify poorly running culprit queries/databases, which end up impacting the entire replica set?
Okay, so what I have understood by this question, basically you have a replica set, right? And you have not enabled query analytics, right? And for those 50, 60 application, they have their own databases within the same replica set. And if you're not have query analytics enabled, even though I would suggest to have it, so either you can have some sort of a proper profiling implementation, not for a longer period of time. Just find out which particular time frame you can get the most out of it, right? And try to not use the profile level 2. So try to use just the profile level 1, which then enables the system.profile collection, and make sure to have proper slow ms parameter there. Like if you afford 200 or 500 millisecond, then have that, or just have 100 millisecond. Apart from this, and if you really think that it is adding a lot of overhead, because obviously it's a lot of overhead, because logging a lot of queries at the same time along with the workload, have some kind of a sample rate as well, right? Out of 10 similar queries, you will be sampling out just one query. So let's say 0.1, not just one. Sample rate default is 1, right? So you can have less sample rate, and even you can have some sort of filter, right? While enabling the query. So similar query pattern will only be get locked within the system.profile collections. But definitely is always recommended to have query analytics enabled, which is basically, it simplifies the entire process for you. Like let's say you as a DBA, you can just head it to the query analytics section, find out the query, select that link itself, go back to the developer if they have the access, tell them, okay, this is how the plan looks like, this is what we are suggesting you. So in order to do all those things, you have to have this. I hope this answers your question.
Great, thank you. I will wait a couple more seconds to see if anybody else has any additional questions they want to ask.
Yep.
All right, that looks like that's it. Thank you very much, Devyanshi, for this great presentation. Thank you, everybody else, for joining us today. If you do have any additional questions, like Devyanshi said, you can email him directly, or you can enter them into the www.percona.com/contact, and you can get questions answered there. Otherwise, we'll see you at the next presentation, and everybody have a great day. Thanks again.
Thanks, Christian. Bye bye. Have a good one.